So this is a very important class. Here we will discuss the relationship between the Planck's radiation law, Stefan Boltzmann law, Wiens displacement law. Now these three laws are all related to thermodynamics. They are all related to the radiation of the black bodies. Okay, so that is what they deal with, and we have discussed them in detail on doorstep tutor. But here specifically we will talk about the relationship between them. See, the basis of the radiation from the black body, or the black body radiation, actually comes from the Planck's law. Planck's law states that a black body at a particular temperature would have a particular radiation profile, which means that if I take the black body, let's say, to 3000 degree Kelvin, then this is the curve I would get for the emitted radiation. The curve actually denotes how much energy is available at a particular wavelength. That is what this curve denotes, and this is a characteristic for the black body at 3000 degree Kelvin or 3000 Kelvin. No matter what the shape of the black body is, no matter where I place the black body, it does not depend on that. If I take the black body to 3000 Kelvin, this is the curve that I am going to get. At 4000 Kelvin, the curve changes, and again it's a characteristic curve for the black body at 4000 Kelvin. This is the radiation profile that I would get, and the same thing happens for 5000 Kelvin, and this is what is known as Planck's law of emission from black body, or just simply said Planck's law. Now when we understand this Planck's law, it means the thing that we have actually seen here is the amount of energy available at a particular wavelength at a particular temperature. This is what this curve actually denotes. Now if I integrate over this curve, if I were to, let's say, integrate over the 3000 Kelvin curve, I would get the total amount of energy which is radiated by the black body at 3000 Kelvin. If I were to integrate over 4000 Kelvin, then I would get the total amount of energy, okay, which is emitted by the black body at 4000 Kelvin. And this actually gives us this integration actually gives us the Stefan Boltzmann law, that how does the energy emitted change with temperature. Okay, so that is the Stefan Boltzmann law. Now the third law that we are talking about is Wiens displacement law. Again we go back to the Planck's law, we go back to these curves, we isolate everything else, and we come up with these curves. Okay, these curves only show the relationship between the temperature and the peak of radiation. Okay, the temperature and the peak of this radiation, and this is what is known as the Wiens displacement law. What does it tell us? It tells us that this peak of this peak wavelength of each of this curve is inversely proportional to the temperature. That is what this tells us. So that was the Wiens displacement law, right? And we can clearly see as the temperature is increasing, the curve, the peak, is actually shifting. It is decreasing in wavelength. Okay, so that is what this Wiens displacement law is. It tells us that it varies inversely. The peak wavelength varies inversely with temperature. So Wiens displacement law, everything can be understood with the help of this Planck's law, and that is what we wanted to talk about in this class. Detailed description of these laws we have discussed on doorstep tutor, both for NEET and for JEE. So you should definitely visit doorsteptutor.com and subscribe or look at the lectures there. Thank you.